So today we're going to do part C of inverses, and we're going to be doing algebraic inverses. So we're going to be dealing with equations and finding the equation's inverse. Okay, so we're going to start off with the steps. Step 1, change f of x to y. Now sometimes it's not always going to be in f of x format, so you can switch that step, but if it's in f of x, let's switch it to y. Step 2, sometimes I have a lot of y'all forget step 2. Step 2 is so important because if you don't do step 2, sometimes you get lost in the solving and you forget what you're solving for. Always switch your x and y, okay? Like we talked about with inverses. Switching, okay? Then you're going to solve for the y and then change the y back to f of inverse of x because you have a new function now once you've done step 3, okay? So real fast, a little example already worked out. So I give you the equation y equals 2x minus 5, and I want to find the inverse. So the first thing they did is they changed f of x to y. So you see it says y equals over here. Next step, they switched their x and y. If you have two x's on the right hand side, when you switch, you'll have two y's. So you switch all your x's to y's and you switch all your y's to x's. So if you look, it now reads x equals 2y minus 5. Then they're going to do the solving process because now you are trying to get y by itself. Okay, so I want to get this guy by itself, so I need to get rid of everybody around it. And in doing that, you work further out. So we're going to add 5 to both sides. That cancels that 5. Now we have x plus 5 equals 2y. Then you're going to divide by that 2. And you have y equals x plus 5 over 2. We change y to f of inverse. Now there's multiple ways to write this, okay? You can say x plus 5 divided by 2, or you can split up and say x divided by 2, or 1/2 x, and then 5 divided by 2, which is 5/2, okay? So we changed f of x to y, we switched our x and our y's, then we solved, and then we changed y to f of inverse x, okay? So we're going to do a bunch of different examples, okay? Let's see here. All right, so let's do some examples. All right, so our first example is going to be f of x equals 12x minus 3. Okay, so step 1 is to change f of x to y. So we're going to switch f of x to y equals 12x minus 3. The next step says to switch your x and your y's. So now I'm going to have x equals 12y minus 3. Now my goal is to get y by itself. Okay? So I need to get this guy right here by himself. Okay? So we got to get rid of stuff. Work your way out in. Okay? So we're going to add a 3 to both sides. That cancels. I'm left with x plus 3 equals 12y. I'm still trying to get this guy by himself. So I need to get rid of that 12, so I'm going to divide by 12. When I do that, I now have f of inverse x equals x plus 3 divided by 12. Now, again, like the example said, you can rewrite this. And we could or write this as x divided by 12 plus 3 divided by 12. And when you clean that up, it's going to be 1/12 x plus 1/4. Okay, so those are 3 different ways you could write it, just depending on how the question is asked. If it asks to write it in the simplest terms, then you will have to reduce. Or if you have multiple choice, being able to recognize that this is equivalent to this is very important with multiple choice. Okay, you just never know how they're going to do it. So you need to make sure you're fully aware that these two are the same, just different format. Okay. All right. So let's do another one. All right. So the next one is going to be f of x equals 1 minus 3x. All right, so same steps. Change f of x to y equals, so it's y equals 1 minus 3x. After you change it to the y equals format, we're going to switch x and y. So now we have x equals 1 minus 3y. And then your goal, like usually when you're solving, like rearranging equations, we want to get that y by itself. So we're going to solve for y, okay? So again, you work your way out to n. So we need to get rid of this 1. It's a positive 1, so we're going to subtract 1. And I get x minus 1 equals negative 3y. That negative comes with it. Okay, we haven't got rid of it yet. Uh-oh. So now we are still trying to get y by itself. So we're going to get rid of that negative 3 by dividing. Okay, that canceled and that canceled. So now we write it in the fancy notation. F of inverse x equals x minus 1 divided by negative 3. Now, I do want to talk about this one because of this negative right here. This negative can be moved multiple different ways. Okay, this can be written so many different ways. All right, that negative, I know on Study Island, you see it written, we all know it's the inverse, so we're just going to say equals. I have seen it written where they pull that negative out. This x minus 1 divided by 3. Okay? Or you can put the negative on top and get 1 minus x divided by 3. And then you could see it as x divided by negative 3. And then that's a negative and a negative, so that's going to make it a positive 1/3. Okay? Or negative 1/3 x plus 1/3. Okay? All of these are the same. I know that's crazy, but they're all the same. All right? It's just knowing that this negative, you can play around with it a little bit. You can throw it out, like it's like pulling it out, or you can put it on top, and on top it just switches the signs. That's really what a negative does. It switches the signs. Then you can distribute that denominator of a 3 to each term, and then we just clean it up with this. Okay? All right. Okay. All right, number 3. So this is going to be f of x equals 5x minus 15 divided by 2. Okay? So, this one, change f of x to y, like we've been doing. Then I get 5x minus 15 divided by 2. The first 2 steps of the last step, they take 2 seconds. The bulk of it is when you're actually just solving for the y. Okay? So we're going to switch that x and y next. So it's going to be x equals 5y minus 15 divided by 2. Now, this one, we're still trying to get that y, I don't know why it switched, that y by itself. All right? So still want to get this guy by himself. So first, before we can touch that numerator, you have to get rid of the denominator. So this is really going to work on your solving skills. All right? So we've got 2x now equals 5y minus 15 because those 2's canceled. Then we're back to what we've been doing in the previous 2 examples. Add the 15. I'm going to come over here, okay, guys? So we have 2x plus 15 equals 5y. Then we're going to divide by the 5. And then we write f of inverse x equals 2x plus 15 divided by 5, Or, I'm only going to write it two ways because these are the two most common ways you're going to see. Or f of inverse x could equal 2 over 5x plus 15 divided by 5 is 3. Okay? They're both the same. All right. Next one. So this next one, if you want to, I think this would be a good time to pause it and try this one by yourself. And see what you can do, okay? So we've got f of x equals 7x plus 18 divided by 2. So pause this video, work it out, and then unpause and check your work, okay? Alright guys, so I hope you paused the video and I hope you tried it. So let's see what you got. So we're going to change f of x to y equals, right? Then we're going to switch our x and y's. Now, I am still trying to get this y by himself. So just like we did in the last example, you've got to get rid of the denominator first. So we're going to multiply both sides by 2. And I get 2x equals 7y plus 18. And then we're back to solving for that y again by, with the linear. So you're going to divide by, subtract 18. Subtract 18. You get, we're going to come back up here. We get 2x minus 18 equals 7y. Then divide by the 7. And now we have f of inverse x equals 2x minus 18 divided by 7. And if you got fancy with it and tried to write it the other way, you would have 2/7 x minus 18 over 7. Okay? Either answer is acceptable. All right? Okay. So let's add some exponents and some radicals. Okay? So our next example is going to be x squared minus 6. So we're going to change f of x to y equals. We're going to switch our x and y's. So even though we've gone different types of equations now, we're going from linear to quadratic, you're still doing the same steps. Okay, now your solving techniques may have to change, okay? But you're doing the same steps. So now we're still solving for y. So before I can get rid of that exponent, I've got to get rid of this 6. So we're going to add 6 to both sides. Now in Math 2, you learned who the inverse, because that's all we've been doing to solve for these inverses. We've been using inverse operations. So subtraction, addition, inverse operation. What is the inverse operation to when you square something? What can undo a square? Well, the inverse of a quadratic is the square root. So we would take the square root of both sides. Now, when you take the square root, you must have a positive and negative, okay? And that is the most missed thing in this problem right here. Anytime you take like the square root, a little side note, the square root of 4 is equal to plus or minus 2, because 2 squared is 4. And negative 2 squared is also 4. Okay, so that's where the plus and minus comes from. So we have to write, so when we write this, because the square and the square root cancel, so y is by itself, it'll be f of inverse x equals plus or minus the square root of x plus 6. Okay? Anytime you take the square root of something, you gotta have the plus and the minus. Okay? Don't forget. Alright, let's do another one. Okay, so this is going to be another quadratic. Okay, so f of x equals x minus 2 squared plus 3. Change f of x to y equals. Switch your x and y's. Alright, remember, work out on your way in. So we're going to get rid of the 3 first. And we get x minus 3 equals y minus 2 squared. You cannot touch these inside until you get rid of that exponent. So we're going to have to take the square root of both sides, because that's the inverse of a square. Now we have, do not forget your plus or minus. Plus or minus the square root of x minus 3 is equal to y minus 2. Easy breezy, get rid of that 2. And now you can put that 2 anywhere. I'm going to put it up front so it looks a little better. 2 plus or minus the square root of x minus 3 equals y. And then we write our final answer as f of inverse x equals 2 plus or minus the square root of x minus 3. Okay? Don't forget that plus or minus. All right, you're missing half of the answer if you only have the plus. Okay? All right. So let's do, I forgot 2 linears. We're going to go do 2 more, or 1 linear. So I did forget this. And a lot of these I'm just doing just to help refresh your memory on solving. Okay? All right, so f of x equals 1/2 x, plus 8. Okay? So we're going to change the f of x to a y. And guys, as you do these more and more, you're going to most likely combine step 1 and 2. You're going to change it to y and switch it at the same time. Okay, and that's fine. But don't rush yourself. So x equals 1/2 y plus 8. Because if you do the same thing over and over again, it's easier to remember. Okay, so work outside to in. So we're going to subtract 8. So the reason I want to do this one is I want to talk about how do you get rid of a fraction. Okay, you're in that upper level math now, and we don't want to divide by that 1/2 because we're going to be doing some problems where that's going to get a little nasty when you're dividing by a fraction. So there's 2 ways to get rid of a fraction. You can A, divide by that fraction, but we don't want to do that anymore. Or B, you can multiply by the reciprocal. Now remember, the reciprocal, okay, is when you flip it. So 1/2's reciprocal is going to be 2. 7/8's reciprocal is going to be 8/7. Okay, and when you multiply these together, it gives you 1, which is what inverses do. Okay, they cancel each other out. So we're actually going to multiply both sides by the reciprocal, which is 2. We're going to have to distribute the 2 over here and get 2x minus 16 equals y. And that is our answer. F of inverse x equals 2x minus 16. Okay, that's all I wanted to do that one, just to show you that it's easier to multiply by the reciprocal than actually divide by the fraction. All right. All right, so we've done some quadratics. Let's do some square roots. Okay. And there are so many inverse problems I could show you. I'm trying to hit the highlights. Okay, but just know that if it asks you to find an inverse function, go by these steps and see what you can do. Okay, so f of x equals the square root of 2x plus 4 all over 3. Okay, so f of x goes to y. And we switch our x and our y's. Now we've solved. So just like we did before when we had a denominator, we got rid of it. So we're going to multiply by 3. And I get 3x equals the square root of 2y plus 4. So if the square root gets rid of the squared, then that means that a squared will get rid of a square root. They go back and forth. So I'm going to square this side, and I'm going to square this side. So the most common mistake here is you're going to write 3x squared. No, 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 no. You're squaring this whole side to get rid of the square root. Then you got to, so that means you got to do what you do to one side, you have to do the other. That means you're going to square this whole side. So that means 3 also needs to be squared. And it's actually 9x squared is equal to 2y plus 4. Okay? Biggest mistake right there. You're squaring the whole side. If just x was over here, then yeah, it would be x squared. But since it had a number, you got to do it all. Okay? So then we go back and we subtract the 4. I'm going to come over here again. You get 9x squared minus 4 equals 2y. Okay? Divide by the 2. So f of inverse x equals 9x squared minus 4 divided by 2. Okay? So just little things you got to make sure you take care of. Okay? All right. So let's do, now, you noticed, let me erase this. Let's do a quick flashback. We've got 2, 3, a couple left. But they deal with exponents higher than 2. So I want to do like a little flashback, okay? Alright, so flashback. So we just refreshed our memory that an x squared is canceled out by a squared. So that cancels each other out and gives us an x, okay? Now, if you remember that a square root has an understood index of 2, that's why they cancel each other out. So if you had an x cubed, you would cancel it out. So you cancel a square with a square root. You're going to cancel a cube with a cubed root. And that'll give you x. Do it again. X to the 4th. You would cancel it out with a 4th root. And that'll leave you with an x. Okay? Same thing with x to the 5th. X to the 5th. You would cancel that out with a 5th root. And that'll give you x. So say you had x to the 105 power and you wanted to cancel it out. You would take the 105th root. That's just being dramatic to show you that it cancels it out. Okay? Alright. So anything higher than the 2, the index must match. You must write it. It must match the exponent to cancel it out. Okay? Alright. So next is going to be, and it's vice versa. If you have the 5th root, you would take it to the 5th power. So if you had the 5th root of x, if you take it to the 5th power, they also cancel out and give you x. Okay, the index and the exponent have to match when you're canceling. So let's go to this one. F of x equals 4x cubed. Change it to y equals. Switch your x and y. Alright, remember you work out to n, so we need to get rid of that 4 first. So I'm going to divide by 4 on both sides. Okay, I'm going to rewrite it just so you can see that it's x divided by 4 equals y cubed. To get rid of the cubed, you would have to take the cube root of both sides. And that leaves you with f of inverse x equals the cube root of x over 4. Okay? Alright, so next one. So the next one I want you to pause. I want you to try it. Okay? So I want you to try this next one by yourself. So we have f of x is equal to 2x cubed plus 3. So pause the video and give this one a shot, all right? Alright, so I hope you're joining us back from trying this problem on your own. And now see if you got it right. So we've got y equals 2x cubed plus 3. Switch your x and y's. Now let's solve. So, out to n. I feel like I sounded like Shrek. Minus 3. X minus 3 is equal to, whoops, 2y cubed. Before we can get rid of the exponent, we got to get rid of that 2. We're going to come up here. We got x minus 3 divided by 2. These 2's canceled, equals y cubed. We just talk about to get rid of a cube, you take the cube root. Please don't forget to write your index. But if that is the only thing you didn't do, that's fine. We can work on that. So my final answer will be f of inverse x is equal to the cube root of x minus 3 divided by 2. Okay? Alright, now let's do some higher powers than 3. Okay? Alright. Next one is going to be f of x equals x minus 1 to the 5th plus 2. Okay? So, we are going to change f of x to y equals. Switch x and y. Now let's solve. Subtract the 2. X minus 2 equals y minus 1 to the 5th. So here we have to get rid of that exponent first because everything's inside. Okay, remember you got to get rid of out first. So remember you took the cube root of a cube, so we're going to take the 5th root of the 5th power. Okay, I'm going to rewrite it because it's a little nasty. So the 5th root of x minus 2 is equal to y minus 1. Then we're going to add that 1. Now this 1 is on the outside because it's after we took the 5th root already. So the f of inverse of x is equal to the 5th root of x minus 2 plus 1. Okay? Alright. So this one is going to be, now let's switch to the radicals. So we're going to have f of x is equal to the 4th root of x minus 1. So that's going to be y equals the 4th root of x minus 1. Switch x and y. Let's solve for y. Now remember, out to n, we cannot work on this inside to get rid of that 4th root. To get rid of the 4th root, we have to take it to the 4th power on both sides. So there's only an x over here, so we just have to write x to the 4th is equal to y minus 1. Add the 1 to both sides, and you have f of inverse x is equal to x to the 4th plus 1. Alright, last one. If you want to pause this one also and give it a shot since it is the last one. Okay. Alright. So we have f of x is equal to the cube root of x minus 3. Same thing. Y equals the cube root of x That's 3. Switch your x and y. Now let's start getting rid of stuff. The 3 is not under it, so we need to get rid of it first. We have x plus 3 is equal to the cube root of y. To get rid of the cube root, we have to cube both sides. And honestly, I would leave it as just that. X plus 3 cubed. Okay? So that cubed means that there are 3 of them. Okay? And you could pull those out and get a cubed equation. But I don't think it's going to take it that far. I actually think it's just going to stop here. Okay? Alright, so that is it for inverses with equations.